This continues looking at using right-angled trigonometry to find unknown sides. There's a situation we haven't looked at yet where x is the denominator of the fraction. That is, the unknown side is on the bottom when we substitute our values in. Now, just a quick review of how we find unknown sides. Our steps are first, label the sides. So in this first example, I don't have anything on the hypotenuse. Next to the angle, I've got the adjacent. Opposite the angle, I have the opposite. And my step second is always choose my ratio. Opposite and adjacent are the two sides I've got, so I can use the tan ratio. So I write tan of the angle is opposite over adjacent, making sure I'm doing correct setting out. I'll expect 4 lines of working. My third step, whether I'm finding angles or sides, it's still the same. I substitute in my values. I know the angle, so tan of 23 degrees equals opposite over adjacent. That is x over 3. Now, this sort of question we've learned how to do. You'll notice that x is on the top here, and I want to get x on its own, and it's x divided by 3. So my fourth step of solve just means to get x on its own, I need to multiply both sides by 3. I don't normally show this little times 3 on both sides like that, but we'll just remember what we're doing. And that will mean 3 times tan of 23 degrees is x. And then we can find x because that's x equals, and we just use our calculator. 3 times tan of 23 degrees equals and that's 1.27 meters. Double check, yes, that's shorter than our 3 meter side, and that looks about right. 4 lines of working, we're done. So what we have to do now is look at the sort of questions where x ends up on the bottom, where the 3 is in this first one and the number is on the top. We still follow the same steps. Label our sides. So in this question, I have the hypotenuse, which I've labeled, and I have opposite my angle, so I've got the opposite. So I've got opposite and hypotenuse. My second step, choose the ratio. Opposite and hypotenuse means sine. So I write sine of the angle is opposite over hypotenuse. My third step, substitute in my values. Sine, don't forget, I know the angle of 35 is opposite 6.3 over hypotenuse, which is x. Now this is a little bit tricky. If you remember your algebra and your equation solving, you'll remember we can't do anything while x is on the bottom of a fraction. We've got to get x back up to the top. How do I get rid of a divide by x? I would multiply by x on both sides. Now I'm going to put this next line of working over to the side because I actually don't need you to show this. I'm going to multiply by x on both sides, and I'll get x times sine 35 degrees equals 6.3. So I've multiplied both sides by x. I'll pop that in brackets. and that gets x up to the top, so I don't have to worry about the fact that it's underneath a fraction. But we still don't have x on its own. I've now got x times sine 35. How do I get rid of times by sine 35? I divide by sine 35 on both sides. So sorry about my dodgy writing there. Divide by sine 35 on both sides. And now I'm going to hop back over here, because all I'm going to do is I'm going to take my sine 35 underneath that 6.3, and I'll get x equals 6.3 divided by sine of 35 degrees. And now I've got x and I can calculate it. X equals, go to my calculator, 6.3 divided by sine of 35 degrees. And x is 10.98, which means 11.0 meters. And x is the hypotenuse, so it should be longer, so we're looking quite useful there. That looks about right. Again, 4 lines of working. Still label sides, substitute values in, having chosen the ratio. But when the unknown is on the bottom, we'll end up dividing. Now, some people like this working. Some people just like to remember that when the unknown's on the bottom, we just swap x and the sine, cos, or tan of the angle, and they change positions. Some people like just remembering that when the unknown's on the bottom, we're dividing. I'll show you a slightly different way of showing you working on the second question. But feel free to pause now and try to do the second question on your own. Just because the working will look a tiny bit different, that's okay. We're still doing exactly the same thing. So pause, try to work it through. Okay, so I hope you've got an answer for this question, and we'll see if you're right. Steps, label my sides. X is adjacent, 16 is opposite. Choose my ratio. Opposite and adjacent will be tan of the angle. Substitute in my values. Tan of 16 degrees is, opposite is 16 as well, 16 over x. So my unknown is on the bottom. This tells me I have to divide. Now, something that I find some of my students like is that in the previous questions, when we're finding, oops, scrolled too far. When we're finding x on the top, we end up with the number in front of the sine, cos, or tan and the angle, and a times sign. So some of my students like to always end up with the number in front and a times or divide. So they'd look at this question and say, I'm just going to bring this number out the front as I normally would. 16 and tan of 16 degrees equals x, and they just sort of sneakily cheat a bit and bring the x up, because we know that this will be divide. 16 divided by tan 16 degrees equals x, and then they calculate x. 16 divided by tan of 16 degrees, very complicated having two of the same number, and I've got 55.8, check our units, it's millimeters this time, as my answer. I could have shown the working as I showed you on the first one. It's just some students prefer to just remember if x is on the bottom, we still bring the number over in front, but we make it a divide instead of a times. However you prefer to remember it, you must be able to find an unknown side when x is on the bottom or when the unknown is on the top.